Now we are going to talk about solving quadratic equations using square roots. So basically what we're doing is we're undoing squaring by taking the square root, because squaring and taking the square root are opposite operations, just like adding and subtracting are opposites, just like multiplying and dividing are opposites. So if I want to solve t squared is equal to 400, I'm going to take the square root of t squared in order to get the squared part to cancel and be left with t. But if I do that to one side of the equation, I need to also do it to the other side. So another thing that we have to consider here, and this can be a little bit tricky, but we need to consider that there are two possibilities when you are talking about squaring things. You could have two positive numbers that multiply together to equal a positive, or you could have two negative numbers that multiply together to be a positive. So we have to take both of those into consideration whenever we are solving by taking square roots to get rid of something that's squared, because we don't know if the t value started out as a positive 20 and we multiplied 20 times 20 to get 400, or if the t value started out as two negative 20s, and so we multiplied negative 20 times negative 20 to get a positive 400. So we have to take into consideration both. So our answer is that t could be positive or negative 20. We could also write this as two separate square roots. You don't have to do both, do one or the other, but we could have also said that t is equal to 20 and t is equal to negative 20. And those two separate pieces mean the same thing as this one piece with the positive and negative sign. Now let's take a look at this next example. And what I want to do is go ahead and move this negative 19 over to the other side, because I want just something squared on one side and all of my numbers on the other side. So I'm going to add 19 to both sides in order to move that to the right. So I'll be left with 2k plus 3 in parentheses, and then that whole thing is squared, and that's going to equal 100. So now I'm ready to go ahead and do square roots again. So I'm going to take the square root of the squared term and then also the square root of 100. So if you want to, you can even go in and cross out the square root and the 2, kind of like we crossed out the positive and negative 19 here. Those are going to cancel each other out. What we have to remember again is that we have to consider that when we undid the squaring, that the two things could have been two negatives or two positives that were multiplied together. So we are going to have that 2k plus 3 is equal to either a positive or a negative 10. Since I still have some solving to do here and I have a positive 10 and a negative 10 as possibilities, I want to break this into two equations. 2k plus 3 is equal to a positive 10, or 2k plus 3 is equal to a negative 10. So I need to consider both cases in order to get my two roots. I'm going to solve these just like I would any other algebra equation, moving the 3 over by subtracting it from both sides, which gives me 2k is equal to 7, and then dividing by 2 to give me that k is equal to 7 over 2. So it's okay for these to be fractions. I'm going to do the same thing to this other one. I'm first going to subtract 3 from both sides to leave me with 2k is equal to negative 13, and then divide by 2 to finally get that k is equal to negative 13 over 2. Why don't you try number 6 and see how it goes? Come back here to check your work. Let's walk through our solution. The first thing I notice is that I still have a constant on the left as well as one on the right, so I want to move that to the right by subtracting. Once I do that, I want to simplify this as much as I can before starting to take square roots, because I don't want to deal with a square root of 3 over on this side. So I'm going to divide that out on both sides, leaving me with x squared is equal to 16, and now I'm ready to take the square root. Remember that the squared and the square root cancel each other, just leaving me with an x, and that we need to consider that it could have been two positive 4s or two negative 4s that multiplied together to give us 16. You could alternatively write this as two separate pieces, x equals 4 and x equals negative 4.